Okay, so now that we've talked about sine and cosine graphs, we're going to do the same thing for tangent and cotangent. So again, the idea is we want to go back to college algebra and come to the idea, the conclusion that y equals f of x, and that way we can analyze the graph, look at domain and range, even and oddness, high points, low points, extrema. So all the things we used to do in college algebra, we like to do with tangent and cotangent, just like we did with sine and cosine. So let's begin with tangent. And by definition, right, we know that it is sine of theta divided by my cosine of theta. And right away we can see some problems, because when this is equal to 0, right, what ends up happening is we end up with a division by 0, and that's not good, right? From our college algebra days, we usually had what are called vertical asymptotes occur when that happened. All right, and so when does cosine equal to 0? Well, at pi over 2 and at 3 pi over 2. So one thing we know right away, without doing anything else, right, is that at pi and 2 pi, right, this graph, pi over 2 and 3 pi over 2, right, the graph is going to have vertical asymptotes. And just preparing myself for what was coming up, we even know that's going to happen at negative rotations. So we end up having some issues, asymptotes at those locations. And I think my scale's a little bit off there, but we get the idea, right? So within the full first rotation, we have some problems. Okay, so what I'd like to do, just to kind of take our shirts a little shorter, rather than going through a full rotation in the circle, right, I'm actually going to just go, since we already know we have problems between negative pi over 2 and pi over 2, which on we're either going to rotate 90 degrees or rotate 90 degrees that way and that way, right? Let's go ahead and see what the graph looks like on that patch, and then we'll extend it out. So we already know we have vertical asymptotes at these locations, right? If we consider some other nice values in terms of things, we know that negative pi over 4 and at pi over 4, right, at those locations, the cosine and the sine are actually similar to each other. They're equal. But up here, they're both positive, right? So we're going to basically have that the tangent of pi over 4 is equal to 1, and the tangent of negative pi over 4, when we're down here, all right, the x value is positive, and the y value is negative, so this will be negative 1. So that basically gives us a couple of points to plot, all right, with regard to that. Okay, and then last but not least, we know that the tangent of 0, all right, is 0, because that's sine is 0 and cosine is 1. So putting this together, right, the graph, and with the fact that we have asymptotes, a classic graph for a tangent is this graph right here. And what we're going to find, there's a pi in the middle here. At pi, sine is also 0 and cosine is negative 1, so we're 0 here. And then if we consider 3 pi over 4 and 5 pi over 4, right, those 45-degree angles here, we're going to be negative 1 and positive 1 respectively. So we'll be here and here again. So what ends up happening on a full rotation is this, it's not a wave in the pure sense, but this kind of S shape just keeps repeating itself. So it just keeps repeating itself, and even back here would just keep repeating itself. So everything we need to know about tangent is right there between negative pi over 2 and pi over 2, and that's basically our classic, our classic tangent shape. In terms of points that we're going to manipulate, all right, when we start doing some transformations, we know at negative pi over 2 we have an asymptote, right? At negative pi over 4 we're equal to negative 1. At 0 we're 0. At pi over 4 we're equal to positive 1. And at pi over 2 we're back at an asymptote. All right, and so those are basically the points we're going to manipulate. What also can we see about a tangent graph? Well, things that we've already seen before, right? First of all, the domain, right, would be all x not equal to, some multiple of pi over 2. And it's actually an odd multiple, right? I think the way we do that as we say 2n plus 1, where n is equal to any integer. So at pi over 2, 3 pi over 2, negative pi over 2, 5 pi over 2, 7 pi over 2, our domain consists of all those, and we have asymptotes. I think another thing that we saw earlier is that the range, it's a pretty strong function because it goes up for infinity and down to negative infinity. So the range is just about everything. All right, so we see that. I think some other things we'll notice is that there are no extrema. So unlike the sine and cosine graphs, there's no known extrema here because we're going to positive infinity and we're going to negative infinity for continuation. So there's no extrema. Ooh, I know another thing that we forgot to talk about is the period, right? So all the action happens between negative pi over 2 and pi over 2. So the total length between that action is pi. So that makes it a little bit different than sine and cosine that had a period. We had to go through a full rotation to get the graph. Here we only have to go through a half rotation, if you would, both from a negative and a positive corresponding. But again, if we started here, the graph would come up like so. And I'll show you some animations in a moment. Some other college algebra-like things that we talked about is this is what we call an odd function. Recall that this means that we are symmetric about the origin. And so this point here, if we double flipped it across the x and the y, we have that. Or if you think about rotating everything 180 degrees, we basically have the same graph. So this is definitely an odd function, which means that if we took the tangent of a negative x, that's the same thing as saying negative tangent of x. Okay, so we have a double negative. If we negate the input, we basically negate the output. All right, so those are some college algebra-like behaviors. Of course, what we're going to be doing here shortly is taking this basic tangent-shaped graph and we're going to start manipulating it. We're going to start doing some curve fitting, just like we did with sine and cosine. So that is your basic tangent shape. We're almost 8 minutes into this. Let me pause there, and I'll come back and we'll talk about the cotangent shape. All right, and then we'll analyze it and do all that good stuff. So I will do that shortly in the next video.